It's pretty incredible when you stop and think about it. We live in a time where we can literally restart a heart that has stopped beating. We've got machines that can breathe for us, that can see inside our own cells. The power we have over the human body today is just absolutely staggering. But, and this is a huge but, all of that incredible power comes with an equally incredible burden of responsibility. For every life we figure out how to prolong, this really difficult question pops up. Just because we can do something, does that actually mean we should? So that's the tension we're going to dive into. In this explainer, we're taking a close look at this double-edged sword of medical technology and the moral code, the rulebook really, that we've had to build to try and handle it all wisely. I mean, this pattern is as old as medicine itself. When we see a problem with the human body, our first instinct is to innovate. We build a tool, we engineer a solution. It's true for everything from the very first simplest splint for a broken bone, all the way up to the mind-blowing robotic surgeons we have today. And here's the catch. Every single time we invent a new piece of technology, we also accidentally invent a brand new ethical dilemma that just didn't exist before. A machine that can keep someone alive indefinitely forces us to step back and ask a really profound question. What does it even mean to be alive? So, to really get a grip on this conflict, we first have to understand the tools themselves. What exactly is this technology that gives us so much power over our own bodies? The whole field is called bioinstrumentation, and it's basically the spot where engineering and medicine crash into each other. At its core, it's all about creating devices that can translate the body's hidden signals, its biology, into information that we can actually measure, understand, and then act on. And what's so fascinating is that even the most complex, high-tech machine is usually based on a really simple four-part system. It starts with the measurand, that's just a fancy word for whatever it is you're measuring, say, heart rate. A sensor then detects that property and turns it into a little electrical signal. A signal processor cleans that signal up, makes it stronger and meaningful, and then finally, an output display shows you the result on a screen. And this technology isn't just hiding in some futuristic lab, it's literally everywhere. It's the ventilator breathing for a patient in the ICU, it's the defibrillator shocking a heart back to life in an ambulance, it's the glucose monitor someone with diabetes relies on every single day. And yeah, it's even that fitness tracker on your wrist, constantly measuring your life. Okay, so with all this incredible technological power comes, great responsibility. How do we decide when and how to use it? Well, to navigate these thorny questions, medicine developed a kind of moral compass. And this isn't about just going with a gut feeling. No, it's a formal framework, a set of principles carefully designed to guide doctors, patients, and their families through what can honestly be some of the most difficult decisions a human being ever has to face. And here they are, the 4 core principles. First, you've got autonomy. That's the patient's right to choose or refuse treatment. It's your body, your call. Second is beneficence. This is the doctor's duty to always act in the best interest of the patient. Third is non-maleficence, and this is the famous one. First, do no harm. And finally, there's justice. This is all about the fair distribution of resources that are scarce, like ventilators or donor organs. Now, this is where it all gets really complicated, because in the real world, these principles don't always play nicely together. In fact, they often conflict, especially when you throw advanced technology into the mix. So let's look at this through a couple of case studies. We'll start with a scenario that's unfortunately pretty common and always emotionally charged, the life support dilemma, specifically focusing on a mechanical ventilator. So on one side, you have the principle of beneficence, doing good. This tells the medical team to use the ventilator to preserve life. But what happens if the treatment isn't really preserving life, but just prolonging the dying process? That's when non-maleficence, do no harm, comes in and raises a heartbreaking question. This is the whole concept of medical futility. Is this treatment actually causing harm by just extending suffering without any reasonable hope of recovery? There's this old, grim saying in medicine that just captures this paradox perfectly. We can keep the lungs working, we can keep the heart beating, we can make all the numbers on the monitor look stable, but we might lose the person in the process. The technology worked, but did we actually help the patient? Now, this kind of tension isn't just stuck in the ICU. It's moving right into our daily lives, and in some cases, right onto our bodies. Let's talk about the data we collect about ourselves. The scale of this is just mind-boggling.
There are over 40,000 health and fitness apps on just one app store. And every single one is designed to use the sensors in your phone or your watch to collect incredibly personal data about your body, your habits, and your health.
So autonomy says you have the right to monitor your own health, to access that data. But this creates a huge conflict with confidentiality. I mean, sure, it's your data, but who else gets to see it? Buried in those terms of service, the app company might have the right to sell your data to researchers, advertisers, maybe even insurance companies. All of a sudden, your right to know about yourself is clashing with your right to privacy. So where does all this leave us? Well, the technology isn't slowing down. In fact, it's accelerating. And that means these ethical dilemmas are only going to become more common and a whole lot more complex. I mean, just look at this timeline. It took decades to get from the first artificial kidney to the first PET scan. But now, we're seeing revolutionary breakthroughs like advanced genetic editing happen in just a matter of years. The pace of change is absolutely exponential. And that's really the ultimate takeaway here. Our power is growing faster than our wisdom. For every dollar and every hour we pour into developing new tech, we have to invest just as much in having the difficult, necessary conversations about how to use it ethically. Our moral deliberation has to keep up with our innovation. Which leaves us with one final critical question. In the past, these rules were written by doctors and philosophers. But now, this technology is in our hands, on our phones, and a part of our daily lives. So as our tools become more and more powerful, who gets a seat at the table to write the next chapter of our moral code?